Hello everyone, this is Miss Linda. We'll continue solving IB past paper exams, paper 2. Today we're going to solve question that is related to topic 4, simple harmonic motion, and topic 5, electricity. So part 1 is about simple harmonic motion. An object is placed on a frictionless surface. The object is attached by a spring. So here we have a spring fixed at one end and oscillate at the end of the spring with a simple harmonic motion. So here at the equilibrium position, and when I place the object, so the object is placed distance x, and it starts going back and forth in a simple harmonic motion. The tension F in the spring is given by F equals K times X. K is the spring constant, X is the extension. This is Hooke's law. Show that omega square equals K over M. Omega square is the angular speed or the angular velocity. Now we know from Hooke's law, if we apply the Newton's second law, in Newton's second law, force equals mass times acceleration, and this is the returning force. The returning force minus K because it will return back to the equilibrium position. So if the applied force in this direction, there is always returning force that is opposite to the displacement. So this is the returning force, which equals to Hooke's law. It's opposite to the direction of motion. That's why we put the negative sign. So negative K times X equal mass times acceleration. I need the value of the acceleration. So acceleration will equal minus K over M times X. Minus K over M, this is omega square. So omega square will equal K over M. So I can rewrite the equation as acceleration will equal minus omega square times X. This is part A of the question. Now, part B of the question, we have one cycle of the variation of displacement with time is shown for two separate mass spring system A and B. So I have two different mass spring system. The mass A, it has a displacement 0.2, and mass B, it has maximum displacement 0.1 meter. Calculate the frequency of the oscillation. Now remember, frequency is the opposite of the period. Now period, it's the time it will take to complete one cycle or one oscillation. Now I'm going to look for 2 points that are in phase. In phase, it means they're doing exactly the same thing. So if I start with this point is oscillating up, and this point here is oscillating down. They're not in phase, they're out of phase. But this point here is oscillating up. So the distance between two consecutive points that are in phase, will give me the period. Here I have an x-axis, or the horizontal axis is the period. So the period will equal what? 1.2. So section I have the period T, it's 1.2 second, and frequency will be 1 over T, which means 1 divided by 1.2. And this will give us 0.833 Hertz or second inverse. The spring used in K and B are identical. Identical spring, it means K is the same. Identical spring, which means K is the same constant, same types of spring. K is the same for both. If K is the same, that means omega is the same, because omega depends on what? Depends on K. If, and we know here they have the same frequency. Both of them, they have the same frequency, which is 0.800. So K is the same, frequency always is the same, omega also is the same. that means mass will be the same. Okay, now part C of the question. We have potential energy versus displacement, potential energy in joule and displacement in meter. Here the graph only for mass M, Now draw on the graph to show that the variation of kinetic energy with the displacement for the mass. Kinetic energy for at the maximum, remember when always, if we have kinetic energy maximum, that means potential energy is 0 and vice versa. If the potential energy is maximum, that means kinetic energy should equal 0, but the total energy should equal constant. Total energy, which equals to kinetic energy plus the potential energy, should be constant all the time. So let's go back to the graph, and here this is the potential energy. At the equilibrium, potential energy is 0. At the maximum displacement, which is 0.2, the total energy is 0.16. So if the potential energy is 0, kinetic energy will be maximum, the opposite to each other. So here I will have a maximum kinetic energy at when the potential energy is 0, which means here at the maximum displacement. Okay, the kinetic energy should equal what? 0, the opposite to each other. So here potential energy is maximum, but the kinetic energy will be 0. So I can connect these 3 points together, and this will give me the kinetic energy for mass A. Now, on the same graph, draw the variation of kinetic energy with displacement for mass B. This we have to calculate it first. Now I know for mass A, kinetic energy will equal 0 at the maximum displacement. Maximum displacement from the graph, it was what? 0.2 meter. Total energy in this case will equal potential plus kinetic energy. Kinetic energy is 0. That means the total energy will equal the potential energy. So total energy, the potential energy, it's elastic potential energy that equals to half constant, the spring constant, times the maximum displacement square. Maximum energy from the graph is 0.16. So this one from the graph, it's 0.16 will equal half. I don't have K. Maximum displacement is 0.2 square. Cross multiplication and find K. So K will equal 2 times 0.16 divided by 0.2 square. And this will give us 8 Newton per meter. 8 Newton per meter. Now for mass B, mass B, okay, same thing. Let's just change the color. For mass B, total energy, we'll do the same thing. Total energy, E total, will equal half. Kinetic energy, K, is 8 times the maximum displacement from the graph will be from the graph from here, from this graph, it's 0.1. So times 0.1 square, and this will give us 0.04. 0.04, how can we find it here? Now, from here, I have the maximum number is 0.16, and I have here 5 and 5, 10. I have a 20. So each square will represent 0.16 divided by 20. This will give me 8 times 10 to the power negative 3. Okay, 8 times 10 to the power negative 3 times how many squares will give me 0.4. 8, let me write it here, 8 times 10 to the power negative 3 times how many squares will give me 0.04. So number of squares is 0.04 divided by 8 times 10 to the power negative 3. This will give me 5 squares. 5 squares. So basically it will be here. Here. This one. 0.04 maximum. And this is 0.1, negative 0.1, and here 0.1. And this will represent the kinetic energy for B. Okay, this question is a little bit long. We have part D now of the same question, and it's related to electric current. I have a 24 ohm resistor is made from a conducting wire. The diameter of the wire is 0.3 millimeter. The wire has a resistivity, so this is rho, and this is the diameter. Calculate the length of the wire, and this is easy. We can calculate it. This is part I from this equation. R equal the resistivity times L divided by area, cross multiplication, and find L. So L will be R times the area divided by rho. First, we have to find R. So R is diameter divided by 2. Diameter, it's 0.3 millimeter. Milli times 10 to the power negative 3 divided by 2. And this will give us 0.15 times 10 to the power negative 3 meter. So R is 24. Area, the cross-sectional area is a circle. The area of a circle is pi times the radius square. Radius is 0.15 times 10 to the power negative 3 square divided by resistivity is 1.7 times 10 to the power negative 8. And this will give us 99.79 meter. Now, the relationship here on the axis, draw the graph to show how the resistance of the wire varies with the diameter. Look at the equation. R inversely proportional with the diameter. This is double I. R inversely proportional with area, That means R inversely proportional with the diameter square, or with the radius square. So if I want to draw the relationship 1 over x square, it should give me a curve like that, like this. At 0, 1 over 0 to give me infinity, so resistance is maximum, and then it will decrease as we increase the diameter. So resistance will decrease as we increase the diameter or the radius. 21, it's basically the explain the reason for the difference between the electrical properties of insulating material and the electrical properties of the wire. What is the difference between conductors and insulators? You mention all the difference between conductors and insulators. 21, and 21 is a little bit long. 21, we have a circuit. Electric circuit consists of a supply connected to 24 ohm resistor in parallel with a variable resistor R. The supply has an electromotive force 12 voltage and internal resistance of 11 ohm. Power supplies delivers maximum power to an external circuit when the resistance of the external circuit equals the internal resistance of the power supply. Determine the value of R for this circuit at which the maximum power is delivered to the external resistance. So I need to find R. R and 24, they're connected in parallel. If I add these two resistors, it should give me the equivalent resistance, which is 11 ohm. So since they're connected in parallel, I can use this formula. R equivalent will equal R1 times R2 divided by R1 plus R2, or 1 over R equal 1 over R1 plus 1 over R2. Since there's 2, it's for me it's easier, much easier to use just 1. So just substitute R equivalent. I have 11. R1 is 24. R times R, so 24 plus R. Cross multiplication. So we will have 264 plus 11R will equal 24R. Take this to the other side. So 264 will equal 13R. Divide both sides by 13, divided by 13. So R will equal 20.3 ohm. This is the value of R. Okay. Double I, calculate the reading on the voltmeter for the value of R you determined in the previous section. Okay, this we can use circuit analysis, RIV table. You can use any other method, Kirchhoff's law, or here I'm going to use the circuit analysis. First, I have to find the equivalent resistance for this one. I'm going to call it R1, this one R2, or R, I keep it R, and this is the internal resistance, small r. So first, the equivalent resistance. First step to solve circuit analysis problem, find the internal resistance. So R12 will equal R124 times R, which is 20.3, divided by 24 plus 20.3, and this will give us 10.99 ohm. So the circuit will become like that. We'll have the internal resistance R equal 11 ohm. Here the battery, this is a 12 volt, and here this is R12, which equals 10.99 or 11 ohm. Okay. Second step, I have to find the current now that pass through the circuit. So the current I, this is the current. So I will equal voltage divided by R total, the total resistance. Voltage is 12, R total I have 11. These are connected in series, so 11 plus 10.99, and this will give us 0.545 amp. And then we will do the RIV table, R I V, and we're going to add the power because the second section in the question, he wants us also to find the power. R, small r, I have 11 ohm. R1, 24 ohm. R, 20.3 ohm. Now, the small r, it has the same current I, which is 0.545. How can I find the voltage? From the equation, V equals Ohm's law, I times R. Just multiply these together and we'll get the voltage. The voltage will be 5.955. Okay, now R1 and R2, we're going backward with the circle. R1 and R2, they basically two resistors connected in parallel. So they should have the same voltage. the voltage across R1 and R should be the same. How can I find the voltage? This V1 and 2 plus the voltage across the 11 ohm should give me the total voltage 12. So for total volt, so the voltage across 1 and 2 should be the total voltage minus the voltage across the 11 ohm resistance, which is 5.955, and that will equal 6 volt. And this is the question. Find the voltage, both of them, they will have 6 volt. We can find the current, voltage divided by the resistance, voltage 6 divided by the resistance. And this will be 0.25 and here 0.295. So we're done with calculate the reading of the voltmeter for the value of R. So the reading for voltmeter for the value of R will be 6 volt. Calculate the total power dissipated in the circuit, triple I. Total power dissipated in the circuit, I have to calculate all the powers and add them all. How can I find the power? We have many formula to find the power. Either you multiply I times V, or I can use the power dissipated formula I square times resistor. So the first one, I will have 3.267 if I use any of the formula, I square times R or V square over R or I times V, any of these formulas. Here 1.5, I should get the same answer, and 1.73. So power dissipated, P, will be 3.267 plus 1.5 plus 1.73, and it will give us around 6.5. You should get 6.54 watt or joule per second. That's it. Next video will continue also with the electricity.